Over 6.5 complex numbers in polar form part 1. This is going to be super easy. For those of you guys who forgot what a complex number is, it's basically just a number that represents a point in an imaginary axis. So just to kind of point out a couple really important things is A is usually going to be your real number. B is usually going to be your imaginary number. So that's how you're going to graph it. Now, we're going to have an XY plane. This XY plane is a little bit different because this is actually an imaginary plane. Your x-axis, which would normally be your x-axis, is your real number axis. What would have been your y-axis, which is not going to be your y-axis anymore. This is your imaginary axis. All right, so we're going to go ahead and plot all of those points or equations, I guess, since there are an equation. And starting with the first one, we got 2 and -3. That means we're going to go over, and I'm going to draw and then I'm going to get rid of it. But we're going to go over, starting from the origin, we're going to go over to 2. And then 3i, that means up 3 to the imaginary line. And then that's pretty much it. Pretty easy. Next one, we got -3 and -5. Well, that's going to be -3 to the left and then down to -5 on the imaginary plane. Now we got z, which is -4. This means that there's no imaginary number. So we're going to go all the way to -4, and we're actually just going to stop there. And finally, the last one, we got z is equal to -i. This means that there's no imaginary number, and we're going to go down to -i right there. And that's pretty much it. There's really not much to it. All right, go ahead and turn the page over. And now what we're going to do is, on this section for objective 2, we're going to find the absolute value of a complex number. And we're going to do that really easy. We're really just going to follow that equation or that formula. Remember, A is your real number, B is your imaginary number. So I'm just going to write that real quick. Real and then your I number. All right, so let's do letter A. So letter A is going to be the absolute value of Z, which is equal to the square root of A. Remember, that's A. So that's going to be 12 square plus B, which is going to be 5 square. And notice that we're not including the I. Do not include the I, because otherwise it's going to give you a different answer. Okay. All right. So now what we're going to do is just simplify. You can put in the calculator if you want to, or you can try to simplify it as much as possible. But this eventually gives you, once you simplify the inside, it gives you 169, and the square root of 169 is just 13. So what did we find? Why do we do all of this work? Well, if you think about it, let's just say and I'm only gonna do this for the specific problem. Let's say you got an XY plane or an imaginary plane. This is the I, this is the real, and I want to find 12, 5i. Well, I'm just gonna say that this is 5, this is 10, which means somewhere around here is 12, and then 1, 2, 3, 4, 5. 5i is right there. Well, that point is 12, 5, which is here. What you just found is the distance of that point to the origin. So you found basically the radius, if this was a circle. But we basically just used the distance formula. And notice that we've been using the distance formula a lot. So again, what did you find? You found the distance from this point to that point, which means you are 13 units away from the origin. All right, so that's basically what you're finding. Let's go ahead and complete number 2. So we're going to take the absolute value of Z, which is the square root of A, so 2 square, plus the square root of B, which is -3 square. And again, I'm going to save you some time. If you put that into the calculator, you're going to get the square root of 13. And obviously, we can't really simplify the square root of 13, so that would be your answer. You are radical 13 units away from the origin. And that's pretty much it for today. Good luck on your homework.